Hello and welcome back to another festive coding session with Mr. Jacob. Today, together with my trusty grumpy Grinch mug, we will tackle another installment of the Advent of Languages here. It is day 6 in the month of December, and I decided to do from the 1st to the 24th of December, so on each of the Advent days, an implementation of the same problem in a different language. And the problem that we are going to tackle is actually something very Christmassy. It's drawing this ASCII canvas, ASCII Christmassy art tree in a configurable way. Sometimes with emoji art and sometimes not, in slightly different ways in all kinds of different programming languages. And today I want to actually do a special language which doesn't really have a command line where we could print something to. It doesn't have an std out. Not really, actually. It is a little bit of different. And I'm talking about logo. And actually, let's create for now just a folder 06 logo here to then put later on code in it. And let me show actually to you what this is. So this is actually logo, and let me switch around those windows so that you can better see. And I need to make the font in this thing a little bit bigger here so that you can see actually something. And Logo actually is a turtle-based programming language. So if I do now something like tell it to clear the screen, you are seeing a turtle here. And this turtle can now be controlled, doing something like forward 100, and it prints a line, it draws a line. I can do something like, I can do repetitions, so loops. I can say it to repeat 4 times, going forward like 50 and then turning right by 90 degrees. And if we do this 4 times, what actually happens? Correct, we have a square. And exactly in this way, we can kind of draw out everything that we need there. We have another couple of commands there that we can use to, for example, do something like pen up and then move the turtle around like this. Now it is up there. Without drawing a line, we can set the position to a specific coordinate using a list syntax like this one. For example, I can go to 9090 or something like that, and we will be there. The middle of the drawing screen is always the 0 coordinate, and yeah, I guess we can draw a Christmas tree with that. So let's get going doing this, and let me try to remember what I did with one of my first languages. This was one of my first languages, not my first one, but one of the first languages where I played around with in school, actually. where we learned this one. And it is quite simple, actually, if you get the hang of it, and it's a teaching language, so that's basically the idea of it. However, I thought, why not do this and get going with this one? And I haven't done that for years. I quickly skimmed the manual which comes with this UCS Berkeley logo interpreter here. And yeah, let's try and draw a Christmas tree. I guess we will need to do it a little bit different than we did before, because we are not doing it with ASCII characters. And I actually want to try out a couple of things. And before we then start to really write down our program using logo procedures to store them and load them, we can kind of do that testing here in this logo interpreter there directly. So I guess that's exactly what we want to do. I have already done a little bit of thinking about how we might actually try and draw this tree. However, I've not tried if it works out. What I'm thinking about is moving up to a specific point, then turning the cursor down, and then going with a certain degrees of angle simply to the side, then going in a little bit again, and then repeating the same thing, and therefore creating these these steps. I can only show this in the ASCII demo, of course. So let's go to our Advent of languages and open up the README again. So these kind of steps, these groups, as we called them before each time, I guess that is how we draw them, by simply going down this angle and then going in a little bit again. So yeah, let's see if this actually works out like I think it should. So if we go forward now, like by 300, we are at the top there. Then we say pen down. And now we simply go right 180. And so therefore we are now facing down. And now let's see, we want to kind of repeat this stepping thing there, I guess. So let's do something like repeat, I don't know, 7. And now we actually do 7 times the following. I think we go right a certain angle. No idea actually how much that angle should be. We are facing down, so what would be a good angle for a Christmas tree? I have no idea. Let's just try 30. I've absolutely no idea. Might look horrible. So then we go forward a certain distance. I have no idea as well. We can tweak those parameters later, like something like go forward 50, for example. Now we are at the end of this thing, so we turn left 30, so we are facing downwards again. But wait, no, we need to go inwards a little. So we can go left 90. And now we can go this direction. Let's go forward. I have no idea, something like 10. As I've said, it might look crude, but we get an idea about how we draw this thing. And now we should actually turn down again so that we are in the starting position again. And then we can draw the next zigzag thing there. So I think we then go right 90. And we now let the system repeat this. And I, I think I nailed it. Okay, I hope I can remember the values that I used there, because this actually looks kind of nice. Now doing that on the other side, and we have kind of a Christmas tree. I like that. I think we will kind of go ahead and put that into a procedure then directly. So yeah, let's do that, I guess. In order to do that, actually, that's a little bit unfortunate. I have to actually always stop this logo thingy here and create the file, because you need to start the logo interpreter with the file. However, I guess we can do that. So let's do our hello Xmas dot, I have no idea, LG. I don't think that my Vim set up as a logo highlighting. So now, how do we actually create a procedure? The procedure is actually created with a keyword to. So I'm saying to and then the procedure name. And let me first write it out, and then I explain to you why it's called to. So something like to top left, for example, we could name the procedure. And we can give it then arguments in the following. Like, for example, top left, does this actually need something for us to know? Yeah, the amount of steps that we want to do. So we could name that length. And variables are always started with a colon at the start. And essentially, and the procedure ends with end. And why is it called to now? It's really the natural language word to, and the idea behind it is to teach the logo system to do something. So something like to top left, do the following. You can think of it like that. I'm not sure if I like that or not. It's the way it is. And so now we are essentially doing the same thing, I guess. We are doing repeat, however, now times len. And we want to repeat now the same things that I did before. So we are starting face down. We will actually have to create some sort of init procedure for that. But we will assume we are currently at the top. So let's assume we are at the top. And let's therefore simply go ahead and tell this thing that we want it to do the same. So we need to rotate right. And what was the degree again? I have no idea. I think it was 30 that I thought out to do because it looked nice. Then I went forward 50, I remember that. Then I went left again 30 to get down again, and then I turned to the side. So the question is, do we do that in one, like left 120, or do we do left 30 and left 90? It's completely irrelevant for the logo interpreter. I think this is a little bit more readable. Now we go forward like 10, and then we do, what did Vim do there? It seemed it might be necessary to indent that further. No idea why. And then we, wait a second. Then we go ahead and we are now in. We need right 90 again, exactly to face down again. And if we repeat that len times, it will most likely do the right thing. So now we need another procedure, like, for example, init, we could call that, or init. Yeah, init. We simply call it init. And we give it the initial height of that thing that we want to draw. That makes kind of sense. And so this one will do a clear screen, and then it will do a pen up. It will move up like, I don't know, the height. So I guess we just simply go forward the height, and then it will do pen down again. And this will be our initialization routine. And now we could create a routine called tree, and we give the tree the len. So we could start that there, and we have end here. And now this one could do init, like 300. And then we do top left, like 8 or something like that. And then we need to somehow get back to the start, I guess, and do the same thing for the right part of the tree. So let's maybe just copy this routine here and do top right. And we need to change, of course, a couple of things. So now we need to rotate left here. We need to rotate then right back because we are on the other side now, and left here. So essentially we need to simply inverse all of the angles. We could have done this programmatically, of course, but why bother? So the problem there, however, is we now need to, of course, call top right here with 8 as well. However, in between, we have moved the cursor. So we need to somehow store the cursor position before we started. So maybe we want to do something like, we can actually use local make, I guess it is, which makes a local variable, and we could call that origin or top origin. And we can ask the system where it actually is by using the position function. So this calls the function pos and writes the data into the top origin local variable. And local variable are always local to procedures. We could use make, and make would make this variable global. So now what we can do is, after we have actually drawn stuff here, we can do pen up because we don't want to draw now. Then do set pos, which actually sets the position to a list. So usually you would get it something like 1, 2, 3, 2, 3, 4 or something like that. So that would be X and Y. However, pos here, what we stored here, returns a list. So we can actually do set pos top origin, and as it is a variable, as always, we need to put a colon in front there. So this should actually now move us to the origin point at the start again, and then call top right. And so if we actually execute that, so let's see what happens if we load that logo hello Xmas. At least it didn't complain about something. And if I do now tree, oh, I need to make this bigger, of course, because you can't otherwise read. If I now call our tree procedure and yeah, what was the uh what was our we just gave it the len. I didn't remember what we gave it. So the problem is we didn't even propagate that. So yeah, I guess we will close that up again and quickly quickly fix that before going ahead. So we have len here and len here because we didn't use that parameter, which kind of makes no sense at all. And now we store that. And now I can actually start that. Wait, I'm in the wrong shell. So now I can actually start that here and make it bigger. And this time I remember to put an ampersand at the end, so I don't need the second shell here anymore. And now I should be able to do something like tree 8, and it should not. There's something went wrong. So let's try and figure out what went wrong, actually. So let's do a clear screen. And let's, for now, just do top left and give it something like 3, for example. And it kind of moved upwards. Why did it move upwards? Because we didn't invert the turtle. Yeah, that makes absolute sense. So, and why didn't it draw? Because we are still pen up, I guess. Yeah, okay. So now if we let's do init here, our init function, and we called init and with 300. So yeah, there's our problem. We didn't flip the turtle around. So let's quickly do that. No, we don't want to save the context. So hello Xmas LG. So I guess we kind of made, yeah, the wrong thingy here with our turtle because we needed to do right 180 here to turn down, actually. So let's quickly save that and let's try that again. Let's make it a little bit bigger and say we want a tree 8 or something like that. And we have the left side, but not the right side. However, the turtle seems to be in the correct position, which makes me believe that we somewhere have missed to do a pen down again. So let's quickly see. We are doing on the tree, we are doing pen up, then setting the position, and then before doing top right, we are not doing pen down again. So let's move the pen down here again. Let's call this one again. And let's do tree 8. And now, as you can see, we have already the basic proportions of a Christmas tree and logo. That's actually really nice. So what we need now is we need to somehow need to actually close this shape up like we always do with the dashed lines. So we need to close this shape up and then we need to draw a trunk. So yeah, let's see how we can do that. I guess closing it up might be a little bit complicated because it might involve a lot of trigonometry because we need to calculate those two positions. On the other hand, we can have logo do that for us because we are in our drawing sequence at both of those positions, so we can simply remember that position. That's actually something that we could do. So after we have drawn the top left, we are actually at the end of this position thingy there that we need connect with the other one that we are at the end of when we are at top right. So we could actually do something like local make bottom left, and we are actually now taking the position here after we have actually drawn the left side. That actually makes sense. And after we have drawn the right side, then without getting the pen up again, we are just going back to this position again. That makes sense as well. So let's kind of do that. So by simply doing set pos and then bottom left end, maybe we could call that to make it a little bit clearer. So now this should actually now, hopefully, if we do tree 8, give us a closed tree, and it does. Okay, that's actually quite nice. So now we only need the trunk, and then we are more or less finished. So how would we actually draw the trunk? I guess we can define a procedure called trunk and maybe give it, does it need anything actually? I don't think so. So we are simply defining to trunk, doesn't take anything, so it can simply be live like that. First of all, we need to do pen up. Then we need to ensure that we are at the right position, exactly in the middle uh, of the scroll. Oh, it has a problem there. We don't know where exactly this thing is. So I guess what we want to do is actually, we want to give trunk something. We want to give trunk the Y position where it should start its drawing. So that actually makes sense because now we can take that from the current cursor position Y because we are on this line, so we know where this is. And we can access that somehow. Was it X? No, Y core, I think, like for Y coordinate. That's actually an internal procedure as well, so we can actually use that. And now we should have that in the trunk function there. So we could do something like pen up just to be sure. And let's do a pen down after that just to be sure as well that we don't forget it like before. And now we should be able to do something like set pos. And we need a list here, which contains two values. It contains 0 on the X because we want to be centered in the middle of our screen again. So in the center of our tree there, and Y. And we are using list instead of something like 0Y because this syntax only works for lists, for list literals. And we are creating one with a variable, so we need to use the list procedure and call it with these two arguments. And this creates then in turn a list with these two arguments there. So now we should be exactly in the middle of the tree. So we can go to the side, like we could go, we should make sure that we are correctly oriented, aren't we? Because, or we are, what are we assuming? We are facing down, don't we? No. We are, yes, we are facing down. We have just stopped drawing the tree parts, so we are facing down. Okay, we can work with that, I guess. So let's first of all face right again by doing a left 90. And then we will just go half of the width of the trunk to the side. So I've actually no real idea how much that should be. Something like 30 maybe, then it is 60 fully. So we go forward 30, then we go, we are now oriented that, so we need to turn right. So we are turning right 90, then going forward like, no idea, 80 maybe for the height, might be too much. Then we are going right 90 again, and then we are going forward 30 again, not 300 Vim, but yeah, 30. And then we are going right 90 again, and now we need to go up again, so forward, so the left side up, so forward 30, and this shouldn't have been, wait. This shouldn't have been 30, but 60, because we moved the half here. This is the bottom, actually. That needs to be 60 then. This needs to be 80, because we are going up again. And then we need another right 90, and then we need, just to close this this shape, this rectangle, we go 30 again. And this should actually, hopefully, maybe draw us a trunk. So let's see if it actually does. If we now do tree 8. And as you can see, we now have a tree. And now I would like to, and that's actually really nice looking. So I would like to try something. I would like to, if we even have this environment, to fill this with color. And there is the possibility to do this. And I played around with filling shapes and it did not always work. So I'm not 100% sure this works now. So what I want to do here is now I want to do something like after the init, I would like to do something like filled, and filled takes a list of a color. So we want to make the Christmas tree, I guess, green. So it would be 02550. And then it takes a list of operations to draw a shape. And it must be a closed shape, and then it could maybe color it. We will see. And if we are drawing the trunk, which is kind of a closed shape as well, I guess we will do this here, filled. And I have no idea what is a what is a brown color. What is the RGB of a brown color? I have no idea. Let's just make it red now, simply to check that it even works out. So we can then look up brown easily. So let's try, and let's cross our fingers that this works, because I have no idea if this actually works. Tree, no, not in my. I didn't want to put it in the terminal. I want to do it here. Tree 8. That's actually great. Okay, there is some little problem there with a line that we seem to have drawn here. I've no real idea what happened there. That's interesting, actually. A little bug there. Maybe you can check out the repository and find out how this actually happened and what happened there. But as this video is already a little bit longer than I would like it to, because it's longer than the usual things here, and we have a colored, and actually the red one isn't that bad. Actually, we have a colored green and red, or green and trunk colored tree there on the screen. I think we did successfully did our work on the 6th day of our Advent of Languages here on this channel. And I hope you liked it. I hope you liked learning something about logo and how it actually works and what you can do with it. And maybe you had a little bit fun, like me, implementing or watching me implement this stuff. And if you did so, please give the video a like. Subscribe if you want to be informed when the next video comes out, which is usually during the usual day, during the usual year. It is like every week there is a new video, mostly doing something else, doing something interesting here on this channel. So please subscribe if you like to. And leave me a comment if you have any questions, or if you just want to say that you like this stuff, just please leave me a comment. I try to read them all and answer them all. So yeah, I hope to see you in the next one, and have a great day. Bye!